And we're going to keep it very simple. And we're also simplifying it slightly. As you can see here, the balcony doesn't, it doesn't go all the way around, it's not accessible all the way around the building. We're going to simplify this and just, it's basically like a donut balcony. But what we're going to try and do is just illustrate that we're going to create a floor plate, a simple extruded facade, and a glass balustrade, as you can see from these images of the building. These are two separate images, by the way. This is not the two towers next to each other.
Oh yeah, I was actually confused. I was like,
yeah, I
the
just
back
realized
looks
that.
real straight.
Yeah.
Where are the balconies?
Yeah, this is two images, but I should have thought about that before I put it in InDesign, because it kind of looks like a picture of both of them at the same time.
It does. It does.
Yeah, sorry about that. All right, so
yeah, so I'll share.
Yeah, if you share your
again.
screen, and let me go ahead and save. Save. Okay, there we go. As Guillaume is talking, I will go ahead and save what I have made and put it on the Google Drive.
All right. So as Ollie said, this is how the script looks like in my case. Very similar. We have kind of the thread at the top, which is dealing with manual mass that we model in Rhino and simply contoured or sliced in order to get all these floor edges. And then the second thread underneath here, which is a scripted massing, where we went through, modeled the rectangle, moved it up, and rotated it. So at this point, I have these two outputs, and this is a kind of a clean way of organizing your script where, you have at this point two options, and you can, keep going with this one or keep going with this one and kind of flip back and forth in that case. All right, so the first thing we'll do is to create slabs out of this outline curves. So we can simply use extrude. So extrude actually works both. If your input is a surface, it's going to create a solid. If you give a curve, it's going to create simply a vertical surface based on that curve. Or not necessarily vertical, you actually need to give it a direction, which is the little d input here. So for now, I'm going to use the scripted output there. And I'll put this in my base. So we're still orange, and it still says that there is no parameter d. So we need to define this direction here.
Actually, Guillaume, one thing maybe just to add is if you add one more component before the extrude, so we can swap them around.
Oh, that's a good point.
Yeah.
So we can have a little container here, and then start from there. So the benefit of this is that we can simply swap which ones we want to work with. All right, and I'll call this floor outline. So now, as we want to extrude, we need a direction. So we want to go vertical. So again, we'll use the little unit z vector. So you can see how it extruded up. It gives it a little thickness. We're just seeing the edge of the slab really because I'm just using the curve extruded up. So one thing we may want though is to be able to define how tall or how thick this slab is. And this is where you can use this little input to the z vector, which is a factor that sets the length of this vector. So I'll create a new slider. And maybe as we're in meter, I'll do maybe 0.4. So in the chat a little bit, there were a few things regarding sliders. You can actually type in extra decimals. That helps you be more precise instead of going in and edit and adding more digits here. You can type a number with more digits. You can also set the boundaries using the inferior 2. scroll back in the chat if you want to look at that. But here I'll do 0.4. Actually, it looks pretty thin, but I think, let's see. Yeah, I think this is set up to be in feet because my floor to floor is 14 meters, quite a bit. So actually, I'll switch this back feet in this case, and this tower is in Florida after all. Is it working? Oh, I may have said no when it asked me to rescale. I'm just not seeing my window where it asks me whether I want to rescale or not. There we go. Yes. I guess
Maybe
that's crazy.
If you refresh Grasshopper, I think it might update.
No, I think it's correct. It's just that now my manual mass is crazy big.
Oh, right.
So I'll scale this back down.
That is massive. There you go.
A little closer to something real. And so now this is 0.4 still, so it's 0.4 feet now. So I need to go back and actually maybe we'll do 2 feet or maybe 1.5 feet. Let's be a bit optimistic here. All right, and here I'll call this slab thickness. Okay.
Obviously, if you guys are following along in meters, just create appropriate.
Yeah, use
dimensions
number. That makes sense. All right, so we have our extrusions. Now we can use another tool that's called cap holes. So any poly surface or B-rep that have holes in it, which is the case here because we have an open edge on both bottom and top. And if the hole is actually planar, it's going to be able to close it. So there we go. We have our slabs. So I'll create a last little component and call it, so I use B-rep. So this object type is a B-rep. It's a poly surface. And then we can hide all of this. We don't need any more. So that's our first little process. Now, what we're gonna want to do are the facades. So what I'll do is take the floor outline steel and offset it inwards. That describes the location of the slab of the facade, assuming a certain balcony depth. So in order to do that, I'll search for a component called offset curve. All right, my inputs are the curve I want to offset, the distance I want to offset, then the plane for the offset operation. This is kind of optional. It's going to figure it out by itself most of the time. And then corners if you want to do some fancy stuff. But in our case, we just want a simple offset. So you can see here, we offsetted our curve. The issue is by default, the distance is 1 and it goes outwards. So I want to be able to actually change that distance to be maybe, so we are back into feet. Maybe I'll do a nice 10-foot terrace. Have fun. So this is going to be the balcony. Plug this in. But I'm kind of in a pickle here because it's offsetting outwards. So I don't want my facade to be on this side. I want it to offset inside. So I can simply use negative. And so it's going to offset -10. And now we have our lines actually inside the building. So because it's a closed curve, it's actually pretty consistent in the way it works. I believe when you do positive number, it goes outwards. If you do negative, it goes inwards. If it's an open curve, you don't really know necessarily which side it's gonna offset. So one trick for that sometimes is to offset both sides, figure out which one is the shortest if you want the inner one, or the longest if you want the outer one, and just get rid of the other one. But in that case, it's pretty easy. It's consistent. All right, so now we have our curves here, which are our facade base. And you can see they are at the top because we extruded our slabs up. So we could do something similar here where we want to extrude our slabs down, because typically you define the kind of finished floor height. So I'll use this negative component here, copy it and use it there. So now I'm extruding down. So I go in the negative Z direction. And now our curve are on top of the slab. So now I can extrude my facade upwards. And I will use kind of the same setup here. I need a Z vector going up. So I'll get there. And I'll plug this into my direction. Actually, I need to extrude this curve. So this curve is what we need to extrude up, just like we did for the first step of the slab. So using the extrude tool, I use my base curve of my facade. There we go. And it's still missing the direction and the amount. So we're going in the Z direction. You can see I have a short facade here starting. Now the last thing I need is the height of my facade. So you could go and say, like, I want my facade to be, 10 feet tall. Then it doesn't quite work. So you would change it to, it's actually, in that case, I believe I was 14 feet. Yeah, 14 feet floor to floor. And my slab being 1.5, I need 12.5. But this seems like a slightly awkward process, because now that this is correct, if I go back and I decide to change my floor to floor, it's gonna be maybe 12. And suddenly my facade elements are too tall. So this is where you can use a little bit of math to kind of deduct how tall my facade needs to be to always work and not have to change multiple components all the time and doing the math myself. Again, Grasshopper computers, they're great at math, so let's just use them for what they're good at. So what we'll do to keep the script clean and not drag this all the way, I'll create a little number box here. And I'll rename it floor to floor, just the same way we've defined here. Plug this in, and this is going to be just a little side path for my number to travel all the way to where I need it. This is also a nice way to keep your canvas clean and not have enough. You want to kind of try to avoid these things where spaghettis start to cross other spaghettis, because it becomes quickly unmanageable. There we go. And actually, I want it all the way here. Okay, and now I'm gonna delete this. Now I have my floor to floor height, and I described my slab thickness here. So I can simply do subtraction using floor to floor minus, and I'll do the same little trick here using a little container for my number, calling this slab thickness. By the way, there is another little trick that I like. If you create a new component and you drag and press Alt just once, this arrow turns red. And as you connect it, it's automatically renaming your new component to what it connects with. So nice in order to not have to type the same thing all the time. Now I bring this here, and I do my floor to floor height minus my slab thickness. This is going to give me the actual height of the facade I want. So I guess in that case 10.5. So I had a 12-foot floor to floor minus 1.5. That seems to be correct. And I can now plug this in and have my extrusion be the right height. And now I don't need to mess around with my facade height anymore. If I go back and change my floor to floor, you can see it adapts all the time, and I don't have to worry about it. All right, so now we have our floor slab. I'm gonna tie this up a little bit, otherwise Oliver is gonna be pissed at me. So these are my slabs here, and then I have my facade coming up out from here. Now the last thing I want to do, I'm gonna hide a few things here that I don't need. Right, and the last thing I want to do is the guardrail, which is going to be very similar to the facade we just did. And I'm going to simply duplicate the process I just had here. So I can take all of this, copy, paste, move it down a little. All right, so I'm still using my floor outline. In that case, I'm not changing my balcony depth, but I'm changing my guardrail set. Still want it negative because I still want to go inwards. So I'll show this. And then, of course, the offset needs to be a little bit smaller. We'll do just 1. And then the height needs to change now. This calculation I had doesn't apply, so I'm going to disconnect this. And in this case, the handrail is kind of an individual, independent parameter. So I will create a new one, and maybe we'll do 4 feet. It's a bit tall, but it's a tall tower. Guardrail height. And there we go. And I'll rename this to be my guardrail. I have my clean 3 outputs here. My slab, facade, and guardrail. And I can go a little fancy and start looking at it with the custom preview we've used in the past. With a pink slab. Actually make it a nice concrete gray. And then copy this over. Use this to color my facade. We'll do maybe a slightly tinted. You can also change the transparency here. Hide this. And then use the same, could actually use the same color for the glass guardrail. So I keep this plugged in both, so I can change my glass both at the same time if I wanted to. Here is our nice Coco tower. So one thing you see though, we have some slightly weird thing. We have a facade at the top that doesn't connect to a floor because it's the last one. So we could get rid of this one. We also have a slab at the bottom that doesn't necessarily need to happen, and a guardrail at the bottom. So we could go in and remove these. So to do that, we'll need to make sure that we remember our list components or list tools. All right, so these are all my slabs here.
Putting our list to the test.
Yeah. All right, so one, I actually believe we didn't cover it, but there is a call item. Where is it? It's call index. There we go. So I'm going to take all my slabs here. What call index do is simply removing the item at the index I specify here. So my slabs go from index 0 at the bottom, 1, 2, 3, etc. So if I set this to 0, it disappeared.
Yeah, maybe for this list parts, if you can make the Grasshopper window a bit bigger, so you can see the number. Yeah, there you go. If you half screen it. Nice.
Yep. So here I removed my first slab. You can see it's gone. And now I need to remove my first guardrail. So it's going to be exactly the same thing. You could do it a different way where you actually get rid of your curve before creating the guardrail, which would be maybe slightly a better idea, but doesn't change anything all that much, except the process of creating this may take a couple extra nanoseconds. So here, as we talked previously, this is a tree. So if I actually delete the item number 0, it's not exactly what I want to do because it's going to delete item number 0 of every list that I put in. So we'll deal with that at the next class tomorrow. But for now, I'm just flattening. This forces everything to be just a simple list. And then plug this back in. So now we got rid of our first guardrail down here. And then finally, I can get rid of the last piece of facade at the top. Same operation. I'm going to flatten that, and we'll go over what flatten means tomorrow. In that case, I don't want the first one, but I want the last one. And there's a little trick where instead of trying to figure out how many you have to get the index, you can simply do -1, because our list, imagine as a kind of a closed circle, especially because our wrap here is true, then you access the last item by going backwards. And there we go. So make sure if you do want to access a last item by using -1, you want to make sure the little wrap is true. Otherwise, it's not going to really understand what a -1 means. And we'll say that the roof is accessible, so we still need a little guardrail up there.
Boom. We have a tower.
Let's play with it now. Maybe you want to
We'll bring us back.
Change the twist here. Maybe make the twist really happen mostly in the middle. Go really flat at the top and bottom. As you can see, you have no rotation, and it's only a lot of rotation and no rotation again. Maybe we want to change the size of our floor plate or the depth of it. Maybe add more floor.
Yeah, this is the beauty of the computational mass.
Yeah, you set up your logic so everything can go from there.
Yeah. So I think what's also cool is now we kind of forgot about the manual mass, so we can go back and if we hide the manual mass in Rhino, and we'll have to do a cheeky bit of flattening to bypass any problems, which we'll discuss tomorrow.
Yep.
I think this is the cool part is you can, once we've created the script, we've got our parametric massing, but then we can go and apply this exact same thing to our manual massing really quickly. And, it just illustrates the pros and cons of each one. So boom, there you go.
So I did a little bit of cleanup. I forgot to use this output that I created here to do my little switch. So I just created it and reconnected to all the inputs here. Actually, it would look better this way to avoid the cross. You can see how now you can change from the floor outlines that were created from the manual mass and quickly change it to the other one, to the scripted mass.
Nice. So that's pretty much the end of our grasshopping today. I feel like this is, we've thrown a lot of stuff at you guys, but we think this is a good amount to throw at you at the beginning. We've got some questions we can go through, Guillaume, and just ask like how to do it. I think there's one at the beginning. Why do we use a BREP component after the cap, so at the end? So Daniel, I hope this is a bit more clear now, because yeah, you don't need to do it. There's nothing happening with it. It's really just a way, to kind of end the script. Like that's the ending point. That's the thing I want to bake, and I can name it, floors or something like that. It's really just about organizing your script. Like a lot of scripting in the real world for making programs and stuff, a lot of your script is just describing those things. So it's just a nice practice to like end whatever it is you're doing. But yeah, it doesn't do anything. You don't technically need it, so to speak. What else we got? I mean, we've got a question about like how would you play with the list? So, balcony designs, how would you offset a few out and a few in? We've also got another question, like how would we vary the slabs offset? So, this is one where Guillaume, I guess if you zoom in on the offset where you're actually offsetting the balcony, we don't necessarily have to do it, but so hopefully this is where the idea of lists is coming in, right? We have a list of curves and we've given it one input. So it's just offsetting the curves by one distance. If we wanted to play with the offsets to be different on each floor, then we would have to input 10 different, or however many floor plates there are. We would have to offset a list of numbers the same length of that, right? So really you can kind of see Guillaume's just like very quickly giving it a go. But you can see that, now I have all these random offsets. In this case, Guillaume is just manually doing it. We could do it with random numbers. But yeah, so you can see a component, you can have multiple inputs and a single input that's driving it. If you wanted to create variation, then you'd create multiple, a list of multiple numbers for the offset. So this is a really simple one, a series. We're also using a series. So like as you go up the building, the tower offset, yeah, it's getting more and more. So I mean, it's kind of fun actually. It's like an invert of the twist or something like that.
Yeah.
So it's really, this is where again it's like that listing. If you match the list, you can kind of manipulate the design a bit. What else we got? How can we take the top extrusion out by using lists? Well, Guillaume went through, we culled the list. We could also we could have shifted the list and then shifted it out of existence. What else could we have done, Guillaume? We could have split the list based on its total number and then just -1. There's many different ways we could do it. We ended up doing it with a very simple solution. We just deleted them at the end, so to speak. But it's quick and effective and it works. So yeah, that's a simple one. So that's why we use double number components. I don't know what that was specific for. If there's time left, can we create columns too? Yeah, I try to avoid creating columns because in the computational mass, it's fairly easy. But in the in the manual one, it's a little tricky because it's doing it. But essentially, you'd offset the floor plate in one more time, offset the facade in one more time, and then if you divide each curve by a fixed number, you could create the points. Yeah, there you go. You could create a points and then basically flip. I don't know if should we quickly do it or.
I could just simply do the very beginning of it. I think I would
Yeah. So
Well,
yeah,
you want to use some offset of this, but I'll do it as if the columns were outside.
yeah. If you
So
do,
yeah, if you explode, you get the the corner points,
yeah.
and
Uh,
they are listed. It gets into trees a little bit.
Well, what if you just divide that curve by 4? Let's say let's just pick a number 4. Yeah, no, explode. Do the explode thing and just divide it by a fixed number. We're doing this on the fly now, so we're entering dangerous ground. Yeah, divide it by, like, let's say 4, right? And then the one component I want to show you guys is called flip matrix.
Yeah. So this is where it gets a little bit in the trees.
Yeah, we are in we are in the trees. This will explain tomorrow, but flip matrix. We won't go into exactly what it does, but um, I think this should work if you put the points into the
Yeah, you
flip
would.
matrix.
So it's a little bit more than this. It's actually flip would work out of this because this is a tree
Yeah,
with just 2 levels, and then you would be able to kind of connect them together.
yeah, interpolate, and then, but we don't have the point. What if you put the points in and oh yeah, it won't.
Oh, I'm not taking the vertices. There we go. So here I recreated these. Here we have a tree with like kind of two. Um, I guess
Try it. See what happens. Does it
yeah.
break?
I would trim the tree first. this
Yeah.
is this is going. This
This
is
is why we
going
didn't
nuts
want to show
again.
you the columns, because we're taking you down a path of tomorrow. There
Yeah.
you go. So yeah. Um, so yeah, but you know, you ask and we will deliver.
Give me more.
Animate. Can we animate the iterations? You can do. We won't show that, but like, well, what you could do. Okay, Guillaume, if you go to the rotation, where it says
Mm,
45. The rotation is in the middle, I think.
it's
Yeah,
oh
yeah.
there.
So what Grasshopper does have is an animate. You can animate sliders as an animate function. This is how we do our Grasshopper animations, which you can see on YouTube exactly how to do them. So I'd point you to that video. And you could, for example, what it will do is it will take a series of images as it's sliding from the smallest to the largest. So you could make a little animation of the tower twisting slowly, and then you just add the images together in Premiere, essentially. But yeah, we won't do that. You can find us on YouTube. There's a video on how to make exactly that kind of animation. Except 3D modeling. Yeah, this is a good question. Except 3D modeling, I know offices use Grasshopper for data analysis, like analyze the sun, wind. The Freedom Tower is an example. Which part is most useful to big architectural offices? It's hard to say which is most useful. I think, the design iterations for a design firm is still going to be number one. We have a sustainability aspect where it uses Grasshopper as a way to analyze buildings and things like that. It can depend on what kind of architecture firm you are. If you're more of an executive architect, maybe you're using Grasshopper more to optimize things around construction and constructability and stuff like that. If you're more of a design firm, you're probably iterating through design and using it for sustainability, credential analysis and stuff like that. So it's a little bit difficult to say. At a certain point, the sun and wind and things like that are taken into more bespoke software. Grasshopper can do quite complex analysis, but they will have their own specific softwares at a certain point.
What's great
Uh,
on the analysis side is that actually, like Ladybug and others, they existed as kind of software where you needed to kind of import your geometry, run the analysis, etc. And a lot of them, even in the structural analysis softwares, they created their bridge within Grasshopper, so you don't really have to access the other software anymore. It's kind of like calling all the the functions of the software in the background, and you stay within Rhino, and you can still manipulate everything and get live feedback.
Yeah. Yeah, I think a few other little questions. I think it looks like some people got a little bit lost at some point, but that's totally fine. What I'll do is, because we had a bit of a unit mix, I will add the complete script to match the one. So there's a part 1 script already in there. I'll put a part 2 script, which is the complete one, which follows on from that same mass. So it's all done. So you guys can follow along. I'll just say incredibly well run tutorial. Thank you. We love a good thanks. Thanks everyone for tuning in. Big help. I like the pun there. So, someone asked, can you edit the objects after baking it? Yeah, you can manually edit the objects after you bake it, but not. You can go back to the script and edit the things you've baked. Once it's baked, it's now in Rhino. And it's separated from the script, but you can go and this is just Rhino geometry, so you can go and edit it and do whatever you want to it. Someone else, does Rhino work nice for 3ds Max geometry, or is it better just to work in one of the two? Yeah, you can go back and forth. I mean, 3ds Max is mainly used for visualization. I don't think many people, model in it. But yeah, they can play together. Yeah, I think that's where we'll wrap it up, Guillaume. This has been a long one. We've done 5 hours. We've come up to. I definitely need a strong drink, but
I need to eat.
Yeah. So I think today is this has been great. Honestly, thank you everyone for tuning in. The response, honestly, we were not expecting this much response on commenting, and it's been really great to have that. Also, join us on the Discord. We'll try to continue to answer questions. I will just give a little bit of a preview of so what's going on tomorrow. Tomorrow will be the second portion of this. So we'll be talking about Grasshopper 102, and we'll be covering tips and tricks of Grasshopper, data trees, what are data trees, and we got a second building script where we'll be playing with the facade using data trees. I think tomorrow will be a lot quicker. I think it'll probably be around the 3-hour mark. But obviously today we're doing introductions and stuff like that. But thank you everyone for joining in. Thank you for liking and subscribing. It really, really helps us. Tomorrow, there's just one thing. If you are in the UK, so the UK is going into daylight saving time or standard time or whatever. Our clocks are changing tonight. So if you are in the UK, we'll be starting an hour later. But for the rest of the world, we'll be starting at 4 p.m. in the UK time. But the rest of the world, it is 3 p.m. If you're confused, just go onto the YouTube link and you can see exactly when it's going to start in your local region to simplify things. So please do come along tomorrow and find the other half of you becoming Grasshopper wizards. Otherwise, Guillaume, have I forgotten anything? I think is there anything else I had to mention? I don't think so.
I think we're good.
I think there's one other thing. There's been a link in the Discord to anyone that if you want a certificate for this, then you can fill in the form, email us, and we'll get in touch and send you a certificate. I know there's some guys from Nigeria where you can actually receive points for attending this course. So I think it's in the Discord. We'll post it in the chat right after this. So you guys can actually fill out the form and get a certificate. Otherwise, thanks everyone for tuning in. We've been blown away by how many people have been commenting and interacting. So yeah, this has been awesome.
Thanks for the people out in India and further east.
Yeah,
being up all night long.
If you're in India, bonus points. I think there's someone that says it's 3 a.m. in this country.
Yeah.
Definite bonus points. We're amazed that you can join us. And we'll see you tomorrow for 102, and that'll be the end of your journey, and you'll be ready to be Grasshopper wizards.
Bye, everyone.
Cool. Bye-bye.